Number 24. A class of 30 students can be broken into different groups. Female or male, full-time, or part-time. And here's a table that shows that. So here's female, male, full-time, part-time, and here's the numbers. 12 are women full-time, 9 are men that are full-time, 6 are women that are part-time, and 3 are men that are part-time. What is the probability that a randomly selected student is female? Okay, so to answer that, what we can do is just add the column for females. That's 18. And let's see, let's add the column for males. That's 12. And if we total 18 plus 12, we get 30. It should add the other way. 12 plus 9 is 21. So it's 21 full-time students, and 6 plus 3 is 9 part-time students. And so to answer this question, the probability of female is going to be the number of females, which is 12, divided by, actually that's not right, the number of females, which is 18, divided by the total number of students, which is 30. So could reduce by dividing the numerator and denominator both by 6. So 18 divided by 6 is 3. 30 divided by 6 is 5, and 3/5 is 0.6. For part B, what is the probability that a randomly selected student is full-time, which is sort of shorthand for saying they are a full-time student. So the probability of full-time is going to be the number of full-time students in total, which is 21, divided by the total number of students, which is 30. We can divide the numerator and denominator by 3 and get 7 over 10, which is 0.7. Part C. What is the probability that a randomly selected student is female and, okay, and is important, and attends full-time, and corresponds to intersection. So this is female, intersection, full-time. So this is going to be the number of female and full-time. All right, it's a little bit hard to see both in this chart. Female and full-time is 12. So I'm going to put 12 up over here. All right, maybe I'll zoom out a little bit. Female and full-time is 12. And there's a total of, in total, 30 students. So there's 12 that are both female and full-time divided by 30. We can divide both of these by 3 and get 4 over 10, which is 0.4. Okay, sort of primitive technology here, but anyway, so okay, all right, let's go on to D. What's the probability that a randomly selected student is female or attends full-time? So find the probability of female or full-time. So this is probability female, union, full-time, and then what we're going to use is the sum rule, which is probability of female plus probability of full-time minus the intersection. And so we already found out the probability of female is 0.60. The probability of full-time is 0.70. Those are just from the problems that came up before. So, you know, up here in A, we got 0.6. That's female, 0.7 full-time. Then we subtract the intersection. So that should be 0.30. And could be 70 minus 40 is 30. Oh no, that's not right. That's 0.90. 6 plus 7 is 13, minus 4 is 9. Okay, so 0.90. All right, now moving on to other problems and a new page. Let's go on to E. And when I do this, I can go up to the top here for part E. And I can look at this again. Okay, for E, we have this conditional probability. Given that a randomly selected student is female, what is the probability that she is also full-time, meaning a full-time student? So what we're trying to do is find the probability of full-time given, and we write that bar, condition on the fact that it's a female. And so the way we do that is we look at the number of full-times that are also female. So we're only going to look at the females. Why would we look at the males? We're asking out of the females, how many are full-time? And so we divide by the females. And so on the chart above here, see, we just look at the females. We're saying, oh, we took the name out of the hat, and it's a female. Forget about looking at the males. So we look at the females. 12 are full time, 6 are part time. So it's 12 out of 18. So that's what we're going to do here. We're going to get there's 12 full time females, and there's 18 females in total. And then when we can divide the numerator and denominator by 6 and get 2/3, which doesn't come out evenly to a fraction, but it's around 0.67. I put that squiggle for around. So it's around 67%. And then, so that's a conditional probability. So your conditional means that you're drawing a student's name at random, so one of the students, but then you're given this information. Oh, by the way, that's a female. So what's the probability that's full time? So you're just sort of, you're putting aside the whole group of males. Don't care about them for that problem. Now we're going to turn this around. Given that a student chosen randomly is full-time. Okay, so you draw a name out of a hat, but there happens to be a full-time student. What is the probability that the student is female? Well, that's not really a good lettering there. That is. Okay, so we're trying to find the probability of female given full-time. So what we're going to do is we're just going to look at the number that are female, and remember, and is intersection, full-time. So we're only looking out of the full-time pool. Don't look at the part-time people. Just look at the full-time, and then say out of those full-time that are female, you take that number and divide by the full-time. Okay, so let's look at this chart above, if I can, and fold the paper in a certain way so that this will work. Okay, so, see what I have here is we're looking at full-time. Don't even look at the part-time. Here, see? We're saying, look, there's 21 full-time students and 12 are female. So we're going to get 12 out of 21. We can reduce this fraction if we feel like it. You can just put in the calculator, do 12 divided by 21 and get a decimal approximation. But if I divide by 3, I get 4 out of 7. Divide numerator, denominator by 3. And can't really do that in my head very easily, but well, I sort of could. Because I don't, what this is? This is like, I don't know where I can put my calculator, someplace else. So it's a little bit of laziness, or I don't know what, not being prepared to have my calculator handy. But it's about 57%. I mean, it's not really that hard to do that long division. So, okay, that's all.